Here's how to set up, use, and get the most out of your Horizons microscope camera. There are a couple of different ways to use this thing. You can either mount it directly onto the trinocular port with a C-mount connection. This is a threaded connection, which I'll measure and show you how to figure out if your microscope has C-mount. Or you can use the included eyepiece adapter, and you just thread this in, and then it can fit directly in place of one of your eyepieces. Sometimes different trinocular ports have different mounting styles on them. Sometimes, instead of it being a C-mount adapter, it will actually also be basically the exact same as an eyepiece port, so this can also fit in like this. This is our Horizons microscope that I'm using right here. To figure out if your trinocular port has C-mount threads, you can just go in with a ruler and measure the diameter. It should come out to be 25 millimeters, or for inches, that would be 1 inch. And if your trinocular port has a smooth barrel inside, it's probably just the same size as is for eyepieces. So if you go and measure it, it should come out to be 0.9 inches or 23 millimeters. Different microscopes have different eyepiece diameters, so compare the size of these two. But don't fret, when you buy the kit, it comes with some adapters. Inside the box, you get an assortment of items. You, of course, have the microscope camera itself with a micro SD card that already comes inside of it. You have the remote that works with this. You don't need to add extra batteries. There's a coin cell already in this one. USB cable to connect it to your computer. HDMI cable to connect it directly to a monitor or a TV. The power supply, of course. This C-mount to C-mount little adapter bushing. To be honest, I don't really know what the purpose of this is. It basically just threads in, to C-mount on one side and then has C-mount again on the other side. So maybe, I don't know, if you need for some reason to stand off your microscope camera for another 6 millimeters, you can do that. I really don't get it, to be honest, but it's in here. And then you also have the eyepiece adapter and the 2 eyepiece bushings as well. Something I want to point out about this eyepiece adapter, you'll note that it says 0.5 times on it, and that's because this is also a demagnifying lens. One of the issues that we've heard some people have and other people kind of love about this camera is that the image sensor, which you can see down there, is pretty small. So if you imagine that this was your eyepiece, let's say, and the image of the microscope is coming through this huge hole, and it's getting projected through to there, it's basically only going to pick up what's in the very, very center of it because the image sensor is so small. So it in effect will give you extra magnification. So this eyepiece adapter is demagnifying this image. So imagine this now becomes half the size, projects onto the image sensor, and it much more closely matches what you see when you look through just with your eyes. Now I'd like to do some expectation setting about this camera. We tested a bunch of different cameras from our supplier, and this one was the best for its price point, and it even outcompeted ones that were double the price of it. But just to be clear, you're not going to be instantly out of the box getting internet content creator level microscope videos out of this thing. Because, as is the case with any camera, including the DSLR that I'm shooting this on right now, you have to understand how to adjust the settings correctly. You have to understand how to prepare your sample to make it most idealized for the camera that you're using. And this is also a $200 to $300-ish camera, depending on how much inflation took effect when you buy this camera. But yeah, it's not going to be the same as a $10,000 camera. Sorry. And also, it's not going to be as good as your regular human eyes. Your human eyes are really incredible, and even with the most expensive cameras that you can buy in the world, they still don't quite get up to what your eyes can perceive for a whole range of reasons, which I'm not going to get into in this video. But if you'd like to learn how to optimize this camera and do a really good job taking pictures and videos, get some very high quality content out of it, keep watching this video, because that's what we're going to be going over. The simplest way to start using your microscope camera is to use it via HDMI. Grab yourself a monitor or a TV and just plug it in. Okay, I have the power and the HDMI hooked up. I got my little monitor over here, and let's just plug it in and it should just work. Sometimes though, if it doesn't work out of the gate, you might need to turn on your monitor, of course, which looks like what's happening. And there we go, it just worked in this case. So if your monitor or TV did not immediately just work, there are a couple of things for you to try. Number one, make sure to switch the source. Some of these newer smart TVs are actually really dumb and don't realize that the HDMI port you just plugged in, they don't realize that you actually want to use that. So you have to go and manually switch over the source using the settings or like the little source button on your remote. And then if that still doesn't work, make sure your camera is getting power. Make sure the HDMI cable is plugged in all the way. Otherwise, it just works. I have had some times in the past where like an HDMI cable has gotten a piece of dust in it. HDMI connectors are kind of sensitive actually to dust and whatnot. One other thing I want to point out about HDMI is that you might say, well, my desktop computer has an HDMI plug on the back of it, so could I just plug the HDMI from here into the back of my computer and be able to see it on my computer? The answer is no, absolutely not, because that's not how HDMI works. HDMI has the same kind of plug for whether it's the source or what's actually visualizing that HDMI data coming out of it. So it looks the same on both ends of the plug, but the port on the back of your computer is your graphics card that's outputting a signal for you to be able to see your desktop on a monitor or something like that, and cannot take in inputs. If you want to be able to record what's coming off of an HDMI cable directly, you have to use what's called a capture card, and it basically converts the HDMI signal to USB. But that's kind of pointless in this case because it also just has a USB on it. So if you want to record, you can either do that on the camera itself using the buttons on the top here or the remote to just hit record. It'll record it directly to that micro SD card, or you use a USB. If you want to use the USB function, you do need to install a software on the computer. Let's talk about the remote and setting up options on the camera itself. So my setup here is a little complicated, but essentially what I'm doing, because in order for you to see the menu pop up on the monitor or TV that you're using, you need to be doing it over HDMI. You can't do that over USB to your computer because when you're using the USB mode, you're controlling it via your computer. So I have the HDMI coming out here, going into a capture card. So this thing basically steals the HDMI signal and then turns it into USB that I can then have on my computer, which is what I'm actually using to record. And then it also outputs that same HDMI signal that is going over to a monitor, which I have here out in front of me as well. As you can see, it looks not correct. I have a little remote right here, and I can tell you what's going on already is that it's not it's not doing an auto exposure, so it's too bright right now. What we're going to want to do, hit menu, go to menu, use the arrow keys to go to exposure, and then I'm hitting the right arrow key. Auto, hit auto to, exposure auto to on, and I just hit the right arrow key all of those times, and then that comes through, and it looks correct now, and this is a live feed, of course, and ooh, that looks nice and snappy. High frame rate on that, definitely a higher frame rate than if you're using the USB. So this usually auto exposure will work correctly. However, on certain types of samples, like on dark field as a good example, dark field does not actually work really well with auto exposure on because it'll see so much darkness. It'll say, we need to raise the exposure and make everything brighter, but then the thing you're actually trying to look at, the sample, which should not be really dark in dark field, is now like getting totally blown out and is way too bright, and start, cranking down the exposure. Or you see right there, it looped over to the other side. You can go up to the higher exposures or whatever you want. Next, we got the auto white balance section. So we hit right arrow key to go into that. Sure, auto white balance on. That looks a lot better already. It looks like right now the background should be just basically white essentially, right? So that looks good. You can do it manually if you want to as well. Keep going down. You can go monochrome if you really want to. I don't know why you'd want to do that. Okay, frequency, you will likely want it at 60 hertz. That's standard for most monitors. This could also have something to do with the frequency of the mains power supply. I'm not really sure. I haven't really found a huge difference in that. Okay, going to record size. This is where you can choose if you want it 1080p 60 frames, 4K 30. This will only affect what it records to the SD card as. This does not affect what the HDMI output is. The HDMI will only output 1080p 60 FPS, I believe. I'll go ahead and say it, that the 4K images that you get rather than 1080p are not really that different. In fact, you pretty much can't tell a difference. And the reason for that is because the video resolution is not the limiting factor in this case. It's almost always the clarity of the optics of the microscope and the image sensor itself, but it's usually the objectives. So yeah, I honestly would just leave it at 1080p. If you want to do 4K, maybe you'll be able to, in certain circumstances, get better resolution out of that. You're running into limitations of optics at very small scales. So that was record size. You can also do image resolution. Image resolution can go way higher than that. That might be like 8K or something like that, huge images. But again, just because you have more pixels doesn't mean that the image overall is going to be better. Okay, so now you can also go to brightness. So this is a little bit confusing because this seems like you're just kind of doing exposure, but a little bit different, but it's actually not the same. Exposure is a setting that is on the camera itself and what it is seeing, whereas brightness is what is getting post-processed after the camera sees it and getting pushed to the TV. I think we need to have a chat about ISO. Basically, what's going on here is that when you change the exposure on this camera, it's actually changing ISO. Basically, it's the sensitivity of the image sensor. In the good old days, when they were using film cameras, ISO was a measure of how sensitive the actual chemical components on the film were. And so if you had a higher ISO film, the chemicals would have an easier time reacting to the light. Of course, we don't use film anymore, it's all digital, but the same concept applies. So essentially, when I set up my camera to be recording me right now, I'm actually leaving it in auto ISO, and this camera is also choosing what the ISO is at any given time. It's choosing how sensitive the image sensor is, but you can also, at least on my camera, manually choose what ISO you want. On this camera, you cannot manually choose the ISO. You kind of have to do it secondarily through this exposure route. Let me show what happens when I turn out my film lights and it forces my camera to have to auto-adjust the ISO way up in order to be able to see me. I turned my film studio lights off, and you can see, and I went and I manually raised the ISO way up on my camera because it was just showing kind of a dark room instead of doing what I wanted it to. So, but you can see, you can still see me in this dark room, but the image is kind of noisy. There's all this like flickeriness in it all over the place. So essentially what's happening is that I'm forcing the image sensor on my camera to become way more sensitive, but it's also becoming sensitive to, random noise in the image sensor. And by noise, I mean, literally cosmic rays that come in and touch the image sensor, and it gets excited in one of the pixels, and then that's kind of why you see all this static in the image. So the same thing applies to this camera up here. Basically, changing the exposure kind of changes the ISO, but through like a secondary means. So if you were to increase the exposure, it's also increasing the ISO to be able to see more light or brightness in the image. I'll turn my lights back on. As a fun little thing, my camera is still at, 12,800 ISO or something like that, and you can see I'm completely overblown. So now what's happening is that I'm having way more light getting put onto me, and my image sensor is, pretty unhappy because it's really sensitive right now, and it's getting totally overblown. So these are things that we have to correct for also on our camera for the microscope side. I'm going to turn my ISO back to what it should be. So right now the illuminator on my microscope is turned all the way bright on the brightness, but let's see what happens when I turn the brightness all the way down. So you'll see it went dark for a second and then it was picking itself back up. Basically what's happening is that the image sensor on here is automatically adjusting its ISO to match what the brightness of this image is. And if you look closely, there is way more static on the image. So here's my number one tip for getting the best possible images on this microscope camera, is to basically use as much brightness as you can, because that will reduce noise in your image. This is the same across all different types of cameras. If you change the exposure, let's say we're changing it down, you are now kind of forcing this camera to auto-adjust its ISO a little bit lower to try to match the exposure that you gave it. So this is helpful when, you know, like I was saying, if you're in dark field and you have basically a black background and it sees the black background and it's like, oh no, we need to make this black background not black anymore, even though that's kind of what you want, that's when you would kind of force it to maintain a lower exposure level to keep everything looking correct in dark field. So hope that helped to explain it. But yeah, use more light. Also, so you can either, you know, change the amount of actual brightness down here via the illuminator dimmer knob, or you can, you know, change the condenser aperture on your microscope. So this is all the way open, all the way closed. And of course, it's a little bit hard to tell what's going on because the ISO is constantly readjusting itself to just match whatever I'm doing. So going back to the brightness section here. So basically brightness is the equivalent of me. So I like record this video on my camera and then I took it into my video editing software and I told it to make the brightness brighter. Like, you're not actually getting any new information in, it's just raising all of the levels up. So that's why you kind of want to get the exposure correct in the first place and then change the brightness if you want to. So like the reason you'd want to change the brightness is maybe it's like not actually your camera that's doing anything wrong, it's rather your monitor just looks better with a brighter setting. Anyway, you can go to contrast, change the contrast between a couple of different levels. This is, you know, choose your own contrast adventure, whatever looks best for you. That doesn't look good. That looks a little better. You can change the hue of everything, which is, I believe, just changing where it is on the hue wheel? Or no, maybe this is actually like saturation, basically. Yeah, no, this is just saturation, essentially, how colored your sample is. 3 looks pretty normal. 4 looks kind of overblown, a little too pretty. Okay, edge would be, I believe, the sharpness of the image. Yeah, no, this is totally the sharpness of the image. So this is essentially, I think, doing some post-processing to increase or decrease the sharpness of the image. That is that. Play around with it for your samples. It really depends on what samples you're doing it on. So that's the whole menu side of things. What else can you do on the remote? Because there are there are a lot of buttons on this thing. So you can, let's get out of the menu first. Okay, we're out of the menu. This little icon that looks like an airplane. It's a mirror, should be a mirror. Does that actually not work on this? No, it does. Okay, so it just flips it horizontally or vertically. AE, there is a handy button for turning auto exposure on or off, which we also were able to do in the menu. Same thing with AWB, that's auto white balance. Another handy one is this video icon, is how you start, you know, recording videos, theoretically. There we go. So now I'm recording a video directly to the SD card. That's how you get it on there. And then you just hit it again to stop it. Same thing with the picture mode. It just took a little picture. Also, you can see there are magnification and demagnification icons. This is just a digital zoom. You're not, you know, if we zoom in too far, it doesn't really help you at all. It's not like you're getting like, this isn't the same thing as going to a higher magnification objective. Because now the more you zoom in, now you're just seeing the pixels and you're seeing the noise in the image. So you always want to, when zooming something in, use the objectives on your microscope. That's what your microscope is for. And then secondarily use a digital zoom if you really have to. So to summarize how to take the best possible pictures and videos with this microscope camera as possible, do a couple of things. Number 1, give it as much light as it can take without getting overblown. Number 2, don't use digital zoom. You're instead going to want to use the highest magnification objective that you can. And then number 3, have as flat of a sample as you possibly can. So even, this is a, you know, they used a microtome to make this sample. It's an extremely flat section of a plant stem, but even here you can see that there are different, it's not perfectly flat. There are different focal planes within this sample. So get it as flat as you possibly can, and this problem gets worse and worse at the highest magnification objectives because that's the way that numerical aperture works. And what's numerical aperture, you ask? Well, it is something that I'm not going to explain in this video. Look it up. It's too complicated for me to explain it right now. So yeah, those are the three things. Make sure your sample is stained correctly. And by the way, if you're not using this kind of a microscope and you're instead using a stereo microscope, this should just look good all the time. Basically, things just get way harder the more you magnify in. Smaller objects are way harder to get to look good than bigger objects. But this camera is going to look fantastic when you're looking at circuit boards and stuff like that, because it's actually not the camera itself, right? The camera itself is not what's limiting us right now. It's actually like the microscope side itself. And that's not to say that this is like a bad microscope or anything. We're just running into the nuances and the practical limits of optical physics. What are you going to do? Let's go over a term called Parfocality. This basically just means that two things are in focus at the same time. So ideally, what you would want is that if you have your microscope camera hooked over the trinocular port, the same time you're looking in through the eyepieces, you would want the camera to be in focus at the same time. That's a pretty nice to have. It's not necessary to be able to get really good quality images. It's just, it's nice. So the way to attain that on the Horizons microscope that we're working with right now, oh, and by the way, if you did want to utilize this reduction lens capability on this system, you would want to keep the eyepiece adapter over the C-mount and then just slot this thing in there like that. It makes it really tall and it looks a little weird. So basically what you have to do in order to get something parfocal is that you have to change physically where this camera sits in the up and down direction, because you're matching the focal plane that hits the back of your eye to the focal plane of the image sensor. So where exactly that focus plane is going to be in your trinocular port on your specific microscope is going to depend. So often microscopes on their trinocular ports will have some way of adjusting a tube up and down here. So the way it works on the Horizons camera is that you can basically you can unscrew this thing. I thought it was screwed in way more. But the threads go really deep into this. And so there's this nut on here, but you can expose a ton of threads. So you could theoretically change the height by this much on this system just by choosing how much to screw it in or not to screw it in to make sure to match it to your eyes. And then once you find the setting that works for you when you have the camera on top of it, you can tighten down that nut and then set it, and it should just retain that spot forever and ever. Thank you, jam nuts. Get this hooked up with your computer, you'll want to use the USB cable that was included with the camera. This part is important. Not all USB cables are the same. Sometimes USB cables only have 2 wires in them for power for certain devices. Other USB cables have 4 wires. Other ones have 16 wires, and the list goes on and on. This one has 4 wires, and that's what this system requires. I'm also using a USB-A to USB-C adapter because my laptop doesn't have any USB-A ports on it. So if you don't have USB-A ports, you'll have to pick up one of those. Just loop this on in there and then plug it in. Unfortunately, sometimes these also don't work. There are other issues with USB, such as authentication, where my computer is actually talking to the USB adapter, and the USB adapter is trying to talk to this USB cable, and sometimes it just doesn't work. So, sorry, you can blame the USB consortium for that one. They did a really good job overall, but it's not perfect. Alrighty, you'll need the software to be able to use this on your computer, so you can go to microsafari.org/camera setup, which is probably where you're watching this video right now, and there should be a link in there that will take you to the Google Drive that has the link for the software. Also in there is this Horizons manual. This came from the supplier, Opto EDU. It's not that great. Maybe like this page will be kind of helpful. Otherwise, I would say skip over it, use this video. I think this video is going to be more useful for you. You'll want to go into the software, of course. After Google Drive takes a million years to zip up the file, you'll be able to download it. Want to navigate to your downloads, find this folder you just downloaded. Boom, extract all. You'll want to unzip it. Take just a second. All right, so now this is the extracted file. Open this up. Now, got a couple of things in here. If you're on Mac, use this. If you're on Linux, you don't need my help. Auto run, hit that. Boom, read me first. Nope, install application. Here's the time where if you have a bunch of antivirus software on your computer, it might get really scared that the publisher is unknown, and it might flag out that this is a virus and you should be really careful and stuff like that because it doesn't have a certificate associated with it from like Microsoft or Google or something like that. But you can just hit yes and next, where do you want it in the regular spot? Install it. You're just installing a regular program. All right, cool, run it. Boom, done. It works. That was it. Plug it in. Now you'll notice it detected it. It should just work. If it doesn't, check all your USB cables and everything that I talked about before. It should show up here, H1600 cam. You'll want to click it. Open this new tab of the window, and here it is. It's working, it's live. Oh, I also found out, I didn't actually know this, you can just power this off of USB. You don't need the power connector for USB. You do need it for HDMI. This software, Image View, has a lot of different stuff inside of it. So I'm just going to give kind of a brief overview and give you the opportunity to explore and find all the delightful features that this software has. So you'll see it is live viewing it at 1920 by 1080. I do want to point out though that the image quality that you're going to get through the USB is not going to be as high as if you are recording it directly to the SD card on the camera using the remote to do that when you're using it via HDMI. And the reason for that is because often they will be compressing the image and the video stream in order to get it down the tiny little tubes of the USB cable. And that's how they're able to shove full HD video through a regular USB 2.0 cable, is they're compressing it down. So even when I'm looking at this right now, I can already tell you this does not look quite as good as it does when you're using it via the HDMI connector. But that also could just be an artifact of it displaying on my computer screen in a smaller window within my regular bigger window, and so because of the ratios of the image resolution, it might be kind of making it look not quite as good as well. But anyway, yeah, pretty straightforward. If you want to record the video, hit record. It'll save it to different spots. Another thing, make sure you are in auto exposure mode. If you're not, this is what it's going to look like, and you're going to have to automatically or manually move the exposure around, and not a good time. Just hit auto exposure. There's white balance. You can fool around with that. Also, I do want to point out the remote does not work while you're using USB mode because you can control that instead on your computer. But let's get to the cooler stuff. One thing that you can do with this software is measure stuff. So in order to do that and get real measurements, you're going to want to go over to this custom measurement. This calibrate slide. Just hit yes. So the way to do this is that you'll want to have a microscope slide, a calibration microscope slide that has microscopic little kind of ruler lines on it that'll tell you how big everything is across on a microscopic level. I could not find the one that I own, so we're going to pretend here. So you'll want to have that, and let's say that, you can move this little red line around. Let's say from here to, here, I know that that is actually, 100 micrometers. I'm at, 10 times magnification, yada, yada, yada. Boom, now it's calibrated. So now what you can do is you can draw a regular line and it'll say, okay, this is 85 micrometers across. So here's a kind of cool little thing. You can do stitch mode, and what this will do is that it will allow you to, why is this not working? Oh, interesting. Okay, so this time it defaulted to not having auto exposure, just looks white. Make sure to hit auto expose so that it does the proper readjustments. Okay, That's good that I caught that actually. Now we go to process, stitch, hit the auto exposure. Now I think the optimal way to do this is probably to raster scan your image, and by that I mean you go to the left, then you go to the right, and then you go all the way back. I'm just doing kind of a quick little demo here. But yeah, we have our big image now created. Here's the confusing bit. So you have to go back to process stitch again a second time to end the stitching. And now you can go to File, Save, Save as Stitch 4. Boom. Here's that stitch we made. And I'll admit this is not that pretty because I didn't really optimize any of the camera settings or anything like that. Especially, I mean, the exposure is definitely wrong. And also the better way to be doing this is, so I'm using the lowest magnification objective right now. What you'll want to do is you'll actually want to switch to a higher magnification objective so it's more zoomed in and then capture more of it slower over time. That'll be a way to give you a higher resolution image. And again, this is an example of how it's not going to out of the gate just look incredible, right? You have to know how to optimize these kind of things. But I'll leave you to play around with this system and get these things worked out. That was the video. If you have more questions after this very long setup video, feel free to email us at info@microsafari.org and we will help you as best as we can. Thanks for watching. Thanks for being a customer. See you next time.